All right, so as we go into our topic of dividing polynomials, now out on Google Classroom, I have two separate videos. I have a video that's on strictly long division and a video strictly on synthetic division. It's broken up into two separate videos. Today's lesson will have both of those in the same lesson, okay? So if you need to watch one a little bit more, go out to Google Classroom. You'll see it was something I did over 10 years ago, is what the video is from. So that way, and now all I focus is on that one topic on that video as we do things. And if you don't like me, then go out to YouTube and Google search long division of polynomials, and you'll find somebody else that teaches it. And the same thing with the synthetic division. So this first part we go through, and we're trying to remind you about when you're dividing by a monomial. Remember, a monomial is a one-term thing. When I have a one-term thing on the bottom, technically what I'm allowed to do is I'm allowed to split this up as three separate fractions. I can split this up as my pen's trying to start working, there we go, 6x to the 4 over 3x squared minus 15x cubed over 3x squared plus 3x squared over 3x squared. Again, I'm allowed to do that when the bottom is a one-term thing. When you start putting pluses and minuses between things on the bottom, you can't split it up. Okay, the whole bottom's going to go with each part. Okay, so you can't. So like on the next one here, on number 3 down below, we can't split that up as w squared over w and w squared over 5. We're not allowed to do that. Okay, so now I just go through basically what we learned about exponent laws. 6 divided by 3 is 2. And then I get to subtract my exponents. X to the 4 divided by x squared is x squared. And then I have minus 15 divided by 3 is 5. X cubed divided by x squared is just x. And then now I take something and divide it by itself. The answer is 1. And so this is the simplified answer to the division.
Do you subtract like the 3 and the 2 like in the
Yes.
exponent?
Yes, doing the exponent laws, yes. Yeah, when you're dividing like basis, subtracting the exponents, yes. I just skipped showing it. I just did it. So on the next one, I'm going to do number 2 the same way. Since the bottom is a monomial, I'm going to split up as 21a to the 5b to the 3 over 7ab minus 14a to the 3rd b squared over 7ab plus 63a squared b over 7ab. Now, I'm going to divide the numbers. 21 divided by 7 is 3. And then when they're like letters, I subtract their exponents. So a to the 5th divided by a would be a to the 4th. B cubed divided by b would be b to the 3 minus 1, which is b squared. Minus 14 divided by 7 is 2. And then it's a to the 3rd divided by a, which would be a squared. B squared divided by b to the 1st would be just b. And then I come over to this next one, and I have plus 63 divided by 7 is 9. A squared divided by a is just a, and the b's end up canceling out, so there's no b there. And that's my final answer. Remember, I cannot combine those things together because they don't have the same exponents on both letters. In order to combine those things together in this last step here, I'd have to have this, everybody would have to have a to the 4 and b squared on it. Because when you're adding and subtracting, you've got to match the exponents on all the letters. Okay? Doesn't matter if one exponent matched, all of them have to match. So since a to the 4, b cubed is the biggest set of exponents on a and b, in order to add the numbers out front or subtract, we have to have a4b squared on each of the terms. So that's the simplest version of that one. So that's dividing by a monomial. Now you could set that one up long division. I'm going to hold off doing it. This one here now, we can actually do this one, they say, using factoring. So going back to what we did in quadratics, factoring the top. So with that in mind, they give me an idea that the bottom is w minus 5. And I say, okay, can I factor the numerator? Well, I see it ends in a plus sign. So that's a w minus and a w minus. Factors of 10 are 1 and 10, 2 and 5. How do I add to get 7? 2 and 5. Now that I have common parentheses on the top and bottom, then I now can cross out the common parentheses. And my answer is simplified to be W minus 2. Again, you can't cross off parts of the top and bottom. You have to have common parentheses, like factor parentheses, in order to reduce if you're doing the factoring method. Remember what I talked about earlier about how many times is factoring going to come up in the course of this semester. Okay? This is just one of the two ways it comes up in this chapter. Okay? So as I set up the next problem, they don't have it set up as a fraction, but they do have it set up with a division sign. So I'm going to rewrite it. 4h squared minus 7h minus 2 over h minus 2. I always like putting parentheses around that bottom when it's a binomial, so I don't make the goofy mistake and start crossing off h's, because I'm not allowed to. And no matter how many times I've said it over the years, I will still see, now don't do this, I will still see kids do this. They'll say h cancels with h. It doesn't cancel. Okay? So that the parenthesis kind of gives me as a boundary. If I'm going to do any canceling, h minus 2 as a whole has to go away. So now I'm going to go ahead and factor the top. We have an h plus and an h minus. On the bottom, I have h minus 2. Now, they're giving me an idea that if I'm going to reduce, there should be an h minus 2 in that second parenthesis in order for me to reduce. Now, let's double check that it is. If my a is 4, my c is 2, so that's 1 and 4, 2 and 2, and then this is 1 and 2. I need to subtract to get 7. Well, I can't use the 2 and 2 because that makes everything even, and I won't subtract to get an odd. So I got to use for A, 1 and 4. For my C, I want to make sure I do 1 and 2 in this order so that odd times odd is an odd answer, 4 times 2 is an even answer, and when I subtract, I get a negative 7 here when I just subtract down. So I wanted to make sure when I arranged it that I did odd times odd, even times even, so that I subtract an odd and an even. So I did get my negative 7 in the middle. So that 8 needed to be a minus, so the 2 has to be after a minus. So I can put that 2 after the minus there. The 1 has to go after a plus, so a 1 goes after the plus. 4 has to multiply to negative 2, so that has to go in the other parenthesis away from the minus 2. And that forces, again, technically a 1 in front of the other h, but again, we don't need that. Now, do I have common parentheses on top and bottom? Sure. Those cancel. I'm left with 4h plus 1 as my simplified answer. Now, when you notice that things can factor, when a trinomial factors, we can use that method to help us reduce, to help us simplify. Sometimes, though, the polynomials get too big and it's hard to figure out how to factor. So we have to have an alternative way to do it. And that's what the next two things I'm going to walk you through. Yes, sweetheart?
So, like, when you're dividing, since we divided by h minus 2, can you always assume that one of the,
You can't always assume no. Not from the beginning. You can't always assume that it's that way. You know, we have to factor it first to make sure. And the reason why I say no, we can't always assume, it goes back down to here. If I rewrite this problem based off of what you're saying, can we always assume? And I start thinking about, okay, let me factor the top. It's a plus and a minus. Well, let me go ahead and put an x plus 8 here. Then we have to think about it as I start doing what you asked. Can we go ahead and assume that it's going to have a factor, whatever's on the bottom is on the top? We can't say that because does 43 have any factors? No, it's prime. So we can't always assume it, okay? We can try to see if it works out that way. Here we tried, but then we realized 43 doesn't have any factors besides 1 and 43, so this is not the way I need to go about doing it. Okay, but it's always worth a shot. And what I would do, as I'm looking at it, use the bottom as the go-to as my first factor pair to start pairing up and doing the stuff with. Use the one with the 2 in it. Okay, use the one with the 2 in it. That way, we kind of reduce that. We don't have to go through all the different trials. Okay, so we can use it as a heads up to get through the factoring quicker instead of all the different options. So now this is where, and I'm going to stick with long division first, and then I want to show you how to do some of these problems, the same problem with synthetic division. Okay, when you're given the freedom, when we do an entrance ticket tomorrow, I'm going to give you one problem to do by long division and one problem specifically by synthetic division that I'm expecting to see. I want to see on those problems that method. I'll indicate which method. Okay, and so you're not going to be able to do them both by the same method. I want to see both methods because we need to know both. All right, so with this in mind, long division, going back to, and I'm just trying to find an empty space here to the side, and you can just watch this if you want. When we were younger in elementary school, and we were learning long division in elementary school, and the teacher said, okay, I want you to take 13 and divide it by 3. And we were doing long division. So what we did, we said, okay, the 13 goes in the house, and the 3 goes out front by the door. Any of your elementary teachers use that terminology about being inside the house? Okay, so same kind of premise goes here. Same premise where what's in front of the division sign goes inside the house. So inside the house is the x squared plus 3x minus 43. And what we are dividing by, x plus 8, is outside by the front door. That's the first thing we do. Okay? Whatever's on the bottom of the fraction goes outside the door, top of the fraction's inside, or if it's written horizontally, before the division sign's inside the house, what's after the division sign is outside the door. Here's the challenge part. Here's the new thing. Back when we did long division, we were told, hey, what's the biggest number we can multiply 3 by to go into 13? Well, it was 4. So that would give us a 12, and then we subtracted down, and it gave us a 1. And before we learned about decimals, we wrote down that, hey, we had a remainder of 1. You remember doing that little bit of R and then 1? Okay? So the difference now with polynomials, our goal now is to multiply the first term. All we're worried about is what do I got to multiply x by to match the x squared? So what do I got to multiply an x by to make it an x squared? X. Just an x. So I write that down on top of the box, right above it. I now distribute that x to both terms, and the answer goes underneath in that first line. So x times x is x squared. X times positive 8 is a plus 8x. I'm trying to grab my eraser tool and just erasing that line. Now, this is where we do our little, I should get paid from State Farm. Our State Farm discount double check. The old little, used to be Aaron Rodgers commercial when he was a representative, the discount double check. Do these first 2 matches. Okay, now I'm going to draw my line. Just like long division, we subtract down. So we put a minus sign in front of that whole row is what we put in there. And so as I do my math, I got to carefully say, okay, x squared minus x squared is 0. And then I go through and say, okay, 3x minus 8x is a negative 5x. So it's almost like that negative sign gets distributed into that binomial on the bottom. And you're going straight down. Again, 3 minus 8 is negative 5x. I then bring down the negative 43. Just like we would bring down the next term as we did, dividing into a triple digit or so forth and so on. We just brought down the next term. Now my goal, and I'm going to erase the 0 since we've already talked about it. Now my goal is to multiply again the x to match a negative 5x. What do I multiply x by to make it a negative 5x? Negative 5. So I put a minus 5 is what I put up there in the top. If it was a positive 5, we would put a plus 5. But since we had to multiply by a negative goes up there. Now I distribute that negative 5 to both terms again. That gives me negative 5x and then a minus 40. I did my little look. Yes, they're the same. Now I get to multiply that. Basically, I subtract down or multiply that bottom row by a negative 1. So negative 5x minus a minus 5x, those are opposites. Technically, they cancel and make 0. Now I have negative 43 minus a minus 40. Negative 43 minus a minus 40 is negative 43 plus 40, which is a negative 3. I'm going to go ahead and erase the 0. I technically stopped. Harper, question.
I was confused about how you got negative 40.
I did negative 5. Wow, shoot, eraser tool. I did negative 5 times 8. Because you're going to multiply it by everything that's out front gets multiplied by that number. Not just the x. Not just the first thing. Everybody's sitting out front, and that way they get their place in line underneath the little columns as we're hopefully having like terms. Okay? Now, we don't write. No, I don't know if it'll do it. Oh, I'll try. Wish me luck. Erasing all those arrows. There we go. So we do have a remainder. So did it divide into it evenly? No. All right. So we stop here. We stop when the degree of answer is less than the degree of what we are dividing by. This goes back to yesterday's beginning lesson when we talked about the degrees. If it's a constant, it has a degree of 0. If I see the x there, just an x, it has a degree of 1. If I see x squared, it's got a degree of 2. All right, that was the part of the beginning part of the lesson yesterday, and so forth. So, since I have x to the first power, I have to keep doing this long division process until I get the degree in this answer line to be less than what that degree. Okay? A degree of nothing is smaller than a degree of 1. So that's why I got to stop. All right? I kept going on the previous line because the degrees matched. They were both 1s. Okay? So, but once it's less than what you're dividing by the degree, you stop. And that's your remainder. Our remainder we write as follows. Since it's negative, we do a minus sign. And it's 3 over what are we dividing by? We are dividing by the quantity x plus 8. That's how my answer is written. Okay, we don't write r. At some stage, some of your teachers might have taught you to write it as plus a fraction. You know, like on when I did my little 13 to the side. Some teachers might have said, okay, this is 4 plus 1/3. And then they gravitated or they transitioned into, hey, that's 4 1/3 as a mixed number. Okay? Now, they may not have. Okay? And also, it's been like hours since you've done that. I mean, usually minutes is what we say. It's been a minute since I did that skill. Okay? But it's like, technically, it's like 15,000 minutes since you've done it. All right? So it's been hours. So, you know, with that in mind, in our world, we write our remainder as a sign, plus or minus if it's negative or positive, and you know the number or the amount over what we're dividing by is what we do it with. Now, not expecting you to get it on the first try. We're going to go down to the next example. Okay, the next example down below it. Again, they tell us to use long or synthetic. We're going to do it by long. Okay. Now, we're going to write a little note here off to the side. If we are missing a degree in the sequence as it descends. Put a 0 in that location. Now, right now, we don't have an example of it, but I'll find one real quickly, and we'll do it on the next one. It goes back to lining up our place values is what we're doing, okay? So we are fortunate on like number 7. We start off with n squared, n to the first, and then no n's. We're not missing a term in the descending power of the degrees of our exponents. So now, if you feel comfortable, want to work ahead of Mr. Stevens, more power to you. Go ahead and work ahead of you. We know factoring doesn't work because what is 19? What type of number is 19? Prime. Doesn't have any factors. So I don't have to bother trying to factor with it. Okay? And stuff. If it wasn't, like on the next one, number 8, we're like, hey, 2 has a factor of 1 and 2. I might want to try to factor that one. Okay? But again, that's kind of some of the things that you'd think about. You know, hey, could I do this one by factoring? 19's prime, don't bother. Okay? So n minus 7 goes out in front of the house. 2n squared minus 16n plus 19 goes inside the house. I'll try to scroll that up so the little paper's not blocking some of y'all. All right, now, what do I multiply n by to make it a 2n squared? 2n. So 2n times n is 2n squared. I've got to remember to multiply it to the negative 7. 2n times negative 7 is negative 14n. My first terms are matching, so I'm ready to draw my line, put parentheses around it, and I subtract down. Again, if you want to multiply that negative 1 inside and change the signs, you can do that. Okay? You know, it's all what you want to do. Now, 2n minus 2n, they cancel. Negative 16 minus a minus 14 is a negative 2n. Because technically it's negative 16 plus 14. So it's a minus 2. Bring down the plus 19. Right now my degrees are matching. I have an n and a negative 2n. They're both to the first power. So that means I got to keep going. What do I multiply an n by to make it a negative 2n? A negative 2. Very good. So that gives me negative 2n. Negative 2 times a negative 7 is a positive 14. My n's match. Great. I'm going to set it up to subtract down. Negative 2 minus a minus 2, they cancel. And then 19 minus 14 is a positive 5. And then now I'm ready to write the remainder. It is plus 5 over n minus 7. It's a positive 5, so I got a plus sign there. And then I write it as what the number was or what's left over what I'm dividing by. Coach is going to scroll ahead a little bit. Ooh, here we go. Number 9. Missing powers in the dividend. The dividend is what's in the front. It's what's on top of the fraction. The divisor is what's on the bottom or what you're dividing by. So, again, that's technically the dividend. Dividend. And that was the divisor. Okay? Your answer is your quotient, is what the answer is. So, all right. So, with this in mind, as we set up the structure, k plus 5 on the outside. What term are we missing? We're missing k squared, right? So that means as I write this, I write down k to the third. It doesn't matter if it's a plus or a minus, but I would go ahead and say, okay, plus 0 and then minus 17k plus 32. Now, some teachers will teach you to go ahead and say, hey, you're missing the k squared term, so put a plus 0k squared. All right, you don't have to. but that's what some teachers will end up saying to do. All right, now we're ready to multiply. What do I multiply k by to make it a k to the third power? Yeah, k squared. So k squared times k is k cubed. K squared times positive 5 is a plus 5k squared. Again, we had to put that 0 in so we could line up like terms in our columns. Almost like when we learned how to subtract with vertically and stuff when we were lining up our place values. My k to the thirds match, so I'm ready to put parenthesis and negative out front. The k cubes, they cancel. 0 minus 5k squared is a negative 5k squared. Bring down the negative 17k. What do I multiply a negative 5k squared to make it a... What do I multiply k by to make it a negative 5k squared? Negative 5k. So that gives me a negative 5k squared, and then it's a minus 25k. I'd like to have that in my bank account. Not minus, positive version of it. Then I put parentheses around it, put a negative out front. That's why I always hate using k as a variable, because it makes me think about money that I don't have. All right, so negative 5k squared and minus 5k, they cancel. What's negative 17 plus 25? Yeah, positive 8. So positive 8k, bring down the 32. Again, this is not stuff we can do in our head. All right? It's work that we got to keep track of. And again, if we go to those online methods for grabbing answers for problems, we're never going to learn the process, and it's going to hinder a lot of stuff that we got to do. Okay? I understand it takes a while. All right, I got to multiply k by a positive 8 to match the 8k that's there. 8 times 5 is plus 40. Subtract down. The 8k's cancel. 32 minus 40 is a negative 8. So I'm back to saying negative 8 over k plus 5. Did any of these ones that we have practiced, did any of them divide into it evenly? No. How do we know if something divides into it evenly? Yeah, there'd be no remainder. The remainder would be 0. We would get a 0 at that last step. It would 0 out. All right, just like when we did with regular long division in elementary school, same thing goes here. Now we're going to write a little note up here in our columns and our margin up here. Yeah, let's go here. If the remainder is 0, then the term is a factor of the polynomial. And we're going to also put down here also an x-intercept. This is where we make the connection for some stuff. We're going to be asked not by doing graphing, but how do I find the x-intercepts for some of these polynomials? Factoring is one way. But when I can't factor, long division, if I know the remainder is 0, then I know, if the remainder was 0, then that binomial would be divided by, that is one of my x-intercepts. I know that, set it equal to 0, that's my x-intercept for one of them. Okay? All right. Do you want to try one more by yourself? And then we'll do synthetic division? You want to do number 10 by yourself? Let you do a number 10 by yourself. I'll give you a head start. I'm going to stop there. I'm going to stop just because I got to do attendance. But I already got an email saying I didn't do it. And yes. And now I can go and missing JC. And the next row, we're missing Ava and Ella's on a field trip. Eva and back row. She said she was going to be missing Ava. No. And yes, field trip, yes. All right. Oh, that's all you got? There was 0 there because we had a 64. And it's 4, 3, 2, 1, so we only need that 0. Only need that 0. Go ahead, turn off. What? That's not supposed to happen. But if it does, it's okay. You just bring on the next term. If it did, I'm going to catch up to you in a second.
Is that right?
It could happen. You just bring down the next 2 terms. Yep. Yep. That's okay. That's all right. You just bring down the next term, and yeah, it doesn't work, so we can bring down the next term. Yeah. I'm going to catch up to you. I'm going to catch up to you. I know, it's like, oh my goodness, we got pandemonium.
Can we watch Bucket? No,
All right, here we go. Let me catch up to you. All right, we got 8x to the 4th minus 60. Whoops, that's a 4, not a 3. 64x cubed. We are missing the x squared, so we got to put in a plus 0. Then we get to put in a plus 3x minus 28. So we need to put that 0 there. Got to put that 0 there. And then now, what do I multiply x by to make it 8x to the 4th? Well, that's an 8x cubed. That gives 8x to the 4 minus 64x cubed. All right, that's okay. Then we match, so we subtract down. All right, so the first 2 things cancel. Okay, because it's basically their opposites. All right, that's okay. All right, bringing down a 0 ain't going to help me. That's okay. I basically have to bring down the next 2 terms, 3x and the minus 28. So this jumps from 8x cubed, missing of x squareds, and down to the final thing, is what this one's doing. Okay? So now I say, what do I multiply x by to match a 3x? Technically a plus 3. So it's 3x minus 24. And then I would subtract down. The 3x's cancel, and that leaves me a negative 4. And so I have a minus 4 over x minus 8. So this problem cleaned up would look like this. 8x cubed plus 3 minus 4 over x minus 8. That's what it's going to clean up as. So you're missing in the answer the x squared. We're missing the x to the first power, and that's okay. Okay, it just happened when we multiplied to match the first 2 things. It wiped out a bunch of stuff, and that's okay. Again, is x minus 8 a factor of that original polynomial? No, because we had a remainder. If we're left with a remainder, it's not a factor. Okay, so that tells me there's not an x-intercept at 8, at x equals 8. It's not crossing there. Okay, because we didn't get 0 for an answer. Now, let's scroll up. We're going to do some of these by long division. Or not so much, synthetic division. The other type. Okay. It means you get it's like the synthetic version of stuff. It's like, you don't you don't have to use all the bells and whistles, all the parts. All right. Now, here's the stipulation, and you got to listen to this one carefully. Can only use synthetic division when it's 1x and then plus or minus a number. You can't have a coefficient on the x. You can't have a power on that x. It's got to be a linear binomial like what we were doing. So if they show after the division sign it's 2x squared plus 1x plus 3, you can't do synthetic division. If it's 2x squared plus 1, you can't do it. It has to be 1 as the coefficient on that x, no power, and then plus or minus a number. Okay? So now all we've done so far are examples where we can do synthetic division. Okay? Yeah. No, it's okay. So right now, that's why this one's kind of rigged to show that you can do synthetic division with some of the same problems. As we progress, we'll see if we can get into it to where we can see if there's one that we can't. And so later on some of the problems I loaded. So when we do synthetic division, we draw a little box. Just a little box. Down below that box, somewhere, give it some space. Draw a horizontal line. This is our template. It is our template that we use. Now, there's a box. I was told it was a box 40 years ago. It's a box. Okay? I didn't question, well, it's missing the other sides and stuff. It's still a box. Okay? Now, sometimes you do see on some worksheets, you actually see a box there, is what you end up seeing. That's why we call it a box and stuff. But, we were just, So, back in the day, we didn't question why. We just did it and stuff. So, we just said, how high do you want us to jump when you said jump? All right. So, here's what we do. We're going to take the coefficients, or we're going to take actually all the numbers in the first thing, 1, 3, and negative 43. Those numbers get written 1, 3, and negative 43. All right, we write them out even with the box or the right angle. Okay? The backwards L. All right? Now, here's the next part. The opposite of what's in the back parenthesis goes in the little box. So since it says x plus 8, I put a minus 8 in there. Okay? Because technically what we're doing, we're asking, is x equal to negative 8? Is that an x-intercept? That's what we're solving for. And so we're doing the opposite of that number, because again, when we saw things in the factor mode and we set it equal to 0, we said that x equals negative 8 was the x-intercept. All right, when we solved. So I put the opposite of what's in that second parenthesis in the box. Now, the first term, whatever the first leading coefficient is, always gets brought down below the line. So I get in a habit of just drawing an arrow straight down, bring that number down below. Okay? Now what we're going to do is we're going to take that negative 8 and we're going to multiply it by that 1, and the answer goes up underneath the 3. So negative 8 times 1, the answer goes up to where underneath the 3. I now add down. What is 3 minus 8? Negative 5. Okay? Now I do the same thing. I take that negative 8, multiply it diagonally to the negative 5, and the answer goes underneath the 43. Negative 8 times negative 5 is a positive 40. Add down. I get a negative 3. That last cell is my remainder. Is that the same remainder we got to the left? Yes. Okay? That negative 3 is the same remainder we just got over here by long division. Same problem, that's why. Okay?
I like the long division.
All right. Now we got to write the expression answer. Okay? We know that we have minus 3 over x plus 8. That's our remainder. Okay? We go back to here saying, okay, it's negative 3 over that. That's my remainder. The negative 5 is my constant in my problem now. And the 1 is the coefficient on the x. So I have 1x minus 5, which gives me what I have on top of my line up there. Remember, up on top of my line, I have 1x minus 5 minus 3 over x plus 8. So now my answers match.
I don't like this.
I know, but sometimes, we just got to try it. You never know. All right? So, when you get familiar with synthetic division, it's a lot faster of a way sometimes to check to see what the remainder is. Okay? Especially with mental math, because you don't have to keep track of the x's. Yes?
I don't know if I missed it, but how did you get a -5?
How did I get the -5? 3 plus a -8. Added down. I added down. 3 plus a -8, -5. I know. It's okay. Next one. Who invented this? Some crazy math dude that was drinking a lot of wine. All right.
No, it wasn't wine. It was something else.
Skipping over here. Shh. Skipping over here. Number 7. Let's do that one. We already know what the answer is.
Brother.
Let's practice it again with synthetic division. All right. So again, I take the coefficients. I draw my little L or my box. I actually have a problem on the chapter test where that template is set for you, and you got to put the correct things in each cell as you solve to get the remainder. Okay? I'm just giving you a heads up, week out. All right, so I write down 2, -16, and 19. Same thing goes with this one. If you're missing a term, you got to put a 0. We're not missing a term. We went squared first, none, so we're okay. It had an n minus 7, so I put a positive 7 in the little box. I then bring down the first term. Never multiply something to get underneath the first term. So always bring down the first term. Now I multiply. 7 times 2 is 14. The answer goes there. And then I add down. -16 plus 14 is -2. -2 times -7 times -2 is -14. Add down is a +5. There is my remainder. So I know I end with a +5 over n minus 7. Now it's -2, and then it's 2x in front of that.
Steven,
Yes, ma'am.
can I have Giselle Guerrero for early difficulty in next office?
Yes, ma'am. She's on her way.
Thank you.
Is that the same answer we got in purple? Yes. It's trying to let you know that, yes, you can use the same technique, the different techniques, get the same answer. Now, again, synthetic division doesn't always work when that thing you're dividing by is like a y squared minus something, okay, or a 4y plus 2. It's got to be a plain old letter and then something else, okay? So, and we really don't do them with fractions. We stay away from the fraction stuff, all right? So, same thing goes on number 9. Let's do number 9 because that's where we were missing a term. So, on number 9, as I draw my little box and I draw the line, and then we say, okay, my coefficients are 1. I'm missing k squared, so 0, -17, and 32. And if you want to, underneath the 32 at the bottom, you can go ahead and pre-say that, hey, this is my remainder. You can go ahead and make that little box in that bottom right-hand corner your remainder to remind you that, hey, that's where maybe a plus a fraction occurs, if you want, okay? I need to put a -5 in the little box in the top left-hand corner, the little L is what I need to do. Bring down the 1. -5 times 1 is -5. Add down, it's -5. -5 times -5 is +25. Add down is a +8. -5 times +8 is a -40. That gives me a -8. And again, as I write my answer, we know it's -8 over k plus 5. There is a positive 8 in front of it, a negative 5x. I still have one more number, so that means I have 1x squared is what I have in front, okay? So as we start writing our answer, it's remainder, constant, x to the first power, x to the second power. If I still had more numbers, I would do x to the next highest power as I keep going, okay? If one of those things happen to be a 0, then I don't have that x. I would skip to the next one, okay? So if the negative 5 was a 0, we would just say x squared plus 8 minus that, okay? Like this last one over here. Like this last one, we're missing the x squared and the x to the first power. So that one, as we do it, I'll do that one real quickly for you, okay? So on that one, as we set it up, 8 goes in the box. We have 8, negative 64, 0, 0. Oh, sorry, just 1 0. Then 3 and negative 28. I know my remainder is down there, so bring this down. 8 times 8 is 64. Add down is 0. 8 times 0 is 0. Add down is 0. 8 times 0 is 0. Gives me 3. 8 times 3 is 24. Gives me a negative 4. And then now I have minus 4 over x minus 8. I have a positive 3 in front of it. Technically, it's a 0x, and then a 0x squared, and then we have the plus, then we have the 8x cubed in front. But again, we don't write terms or letters when there's a 0 as a coefficient. So we would clean that up as 8x cubed plus 3 minus 4 over x minus 8 is what we would clean that up as. But you would technically assign, as you're going from constant x to the first, x to the second, x to the third, and then we just drop off the ones that have zeros, and we don't write those letters in the final version. Now, it may be good to do that, to do this process right here until you get really comfortable with it, okay? Because the last thing you want to do is say this is 8x plus 3, because that's totally wrong. It's supposed to be 8x cubed plus the 3, and then the so forth. Whenever there's a remainder, it's always written as a fraction. We did not get lucky to get one divided in there evenly, okay? Now, I have some extra problems down here for us to practice, but I want to talk about this factor theorem here, or remainder theorem. If, okay, so what the factor remainder theorem? Oh, how do I want to phrase it to make it easy for us to think about? All right, here we go. So let's try this. If I have f of x is equal to ax squared plus bx plus c, and we say that x is equal to d. We're going to let x equal d, where d is a number, where d equals a number. This is the fancy mathematical talk, is what this is. I don't like doing it that often. The factor or remainder theorem, they're actually listed twice. It says factor theorem, and then there's another definition of the remainder theorem, but they basically both mean the same thing, okay? So what that's saying is, if f, that's junky. If f of d equals 0, then x plus d is a factor of the polynomial. Again, that's saying if I just take the d value, whatever d is, x equal to d, If I take that number, plug it into the equation, and I simplify, and my answer is 0, then I know it's a factor. I know it's an x-intercept at that location is what that's telling me. If f of d does not equal 0, then d is not a factor. And the answer is the remainder. Now, I'm not expecting you to get this without a couple examples being done, okay? Some people were okay with the fancy definitions. But, again, most of the time growing up in math, we don't throw a lot of these fancy algebraic definitions out to you in theorems, okay? Back in my day, yes, they did in school. In middle school and high school, they always used the general theorems, but we kind of gravitated away as teachers from doing that just because it is confusing to look at, okay? So with that in mind, okay, I'm going to use this first example here. F of x is technically equal to x squared plus x minus 17. And I'm trying to see, is x minus 4 a factor? Is that a factor? So by the factor / remainder theorem, if I set x minus 4 equal to 0 and say x is equal to 4, and then now I take my equation and put 4 into it and simplify. If the answer is 0, I know it's a factor. If the answer is not 0, then that's my remainder. So in our example right here, x minus 4 is not a factor. So whether we do long division or synthetic division, so 3 over x minus 4, that's my remainder. That is my remainder. So now let's finish up and let's use synthetic division and figure out, well, what was the first part on that same problem? So if I do synthetic division and I say, okay, it's 1, 1, negative 17, I'm putting a 4 in the little box, bring down the first 1. 4 times 1 is 4. 1 plus 4 is 5. 4 times 5 is 20. Added down is 3. There's my plus 3. There's my remainder. So I know it's plus 3 over x minus 4. And then it is x plus 5 is the rest of what that looks like. So the remainder theorem or factor theorem allows me to find the remainder quickly without doing the synthetic and long division stuff. It allows me to quickly take, well, what am I dividing by? Take that, and again, it only works when it's a binomial like we had for synthetic division. You can't use it when, as I use, for example, as I look at some of these ones I circled in red, all of the problems I circled in red here, you can't use the factor remainder theorem because it's x squared. Okay? We can only use it when it's a normal looking binomial is what I'm dividing by. I can use the factor or remainder theorem with. Okay? So when you notice that you have that and you don't feel like doing synthetic division, you don't feel like doing long division, but you had to spot the remainder because that's what the end of course exam question said. They had the answers and they have these remainders on each one. Well, just take that opposite of the number in the parenthesis, stick it in. What do you get numerically as an answer? What answer has that at the end as your fraction? So I put some problems like this on your homework. Okay? And so I made sure that I tried to put some of these down here to kind of go over. They're asking us to use synthetic division. The way this is phrased is just like what we did up above as negative x cubed minus 2x squared plus 13x minus 10 divided by x plus 5. Okay? That's how we saw it in the beginning of our lesson. Sometimes on our homework tonight, we see it listed just like that. I actually cut and paste some problems from the homework assignment in here and retyped it and stuff. So this is telling me to go ahead as I set up my synthetic division. -1, -2, 13, and -10. And -5 goes in the house, goes in front. When it's not as a binomial and it says x equals, you take that exact number and put it in there. It's only when it's in the parenthesis that you do the opposite. And that's what you got to keep track of how is it started. We bring down the -1. -5 times -1 is +5. -2 plus 5 is 3. -5 times 3 is -15. Add down is -2. -5 times -2 is a +10. Holy smokes, finally at the 9th minute until class ends, we finally get a remainder of 0. We finally got it to 0 out. So does this one have a remainder? No, does not have a remainder. The remainders theorem would have showed that too. I'll show you in a minute. As I write my answer, it's -2, and then in front of that a +3x, and then a -x squared is the answer in front. And when there's no remainder, we don't have to do a fraction. Okay? Now to show you how the remainder theorem, since we divided by an x plus 5, if I take for the remainder theorem, if I do f of -5, that would be -5 cubed minus 2 times -5 squared plus 13 times -5 minus 10. That's -125 minus 2 times 25. That's a -65 minus 10. That would be a +125. That's a -50. That is a negative. I combine those. That's a -75. 125. Technically, that's 75 minus 75, which is 0. So the remainder theorem told me that, hey, I should not get a remainder.